The question given under probability lesson in 2016 past paper is, let A and B be two events of a sample space OM in the usual notation. Probability of event A is simple P, probability of event B is P by 2, and probability of A union B minus probability of A intersection B is given as 2P over 3. So condition given is P greater than 0. P is positive. Find probability of A intersection B in terms of P. So the most common relationship in probability is PA union B equals PA plus PB minus PA intersection B. Probability of A union B is not given directly, but they have given this relationship. So for this part A union B, I am going to attach A intersect B. Then I can substitute 2P over 3 for this. Then I have to do the same thing in right hand side. Since I subtracted P A intersect B in left hand side, I am going to subtract PA intersect B in this side as well. Then it becomes 2 times probability of A intersect B. PA is P, PB is P by 2 minus this is the one which we have to find. Here this is 3P by 2 minus PA intersect B. Now subject probability of A intersect B. So I have shifted this to left hand side. Take 2P over 3 here. When I take the common denominator, it becomes 6. This is 9P minus 4P, which is 5P over 6. That is 2 times what we want. Therefore, probability of A intersect B will be 5P over 12. 5P over 12. Then deduce that if A and B are independent events. Independent events. If A and B are independent, their intersection is equivalent to the product of separate probabilities of these two events. If A and B are independent, the equation is their product is equivalent to their intersection. So what is the intersection? It is 5P over 12 from this answer here. PA is P, PB is P over 2. Now I can cancel 1P with 1P. The reason P is not equivalent to 0. If P was unknown, if this inequality was not given, we can't do this. Since P is positive, it cannot be 0. So I can cancel P in both sides. 2 times 1, 2 times 6. So P is equivalent to 5 over 6. This is the answer.